Hello and welcome to part 31 of the mod making series for locked loop containers. Uh, so I've been working on some stuff for a few hours with this, and I've actually made somewhat surprisingly good progress on it today. And I think it's really compared to yesterday, just because I decided to use a method or process that I've done before, and I already kind of know how to. I know at least I know fairly well or somewhat how to do and how it kind of works. I think that's why this kind of changing of the process compared to what I was trying to do yesterday is went a lot more smoothly this today or whatever as I was working on it. So really the main thing I did was I kind of just said, all right, screw the flags enum thing. Um, Even though I'm sure I could do it the way I was trying to do, and I might do it later on, I don't know. But for right now, I was just having really difficult time trying to kind of understand how I was gonna do it in the way I was trying to, and at the same time being somewhat like readable as well as brief in the code or whatever, not just being a huge mess of confusion. So you know what? This is kind of pointless, I feel like, right now. So let me just do something I've done before and I've proven to myself that it works and everything. So I decided to use a method that I used from one of my other mods, Jewelry Additions. And I basically just took the entire method or whatever process that I used to determine what what and when and what chances there were for the jewelry items to generate within like loot contents, that be it either being house containers, whatever private property, shop shelves, and enemies. And I just basically said, all right, let's just do it this way, the way I did it there. And there are advantages and disadvantages to this method or this process, I know, but at the very least, I know it works, even if it's not perfect. So I just wanted to kind of get something there to have a framework so I could continue on and then hopefully polish it and fix it up later where I think it needs fixing and everything. So yeah, I just made another replacement enum value basically for what I commented out for the flags one. And it just has all the materials in it called permitted materials, wood to Daedric. And in the main, well, I mean, in the chest generation method, the thing that I've been mostly working on the past few, like week or whatever, I changed a few other things here. So these permitted materials, none, fireproof, all. These are not even really necessary per se. I just did them to make it a little bit easier for myself with how I did it here, because I had to replace all the stuff that was previously using the thing with the flags and the binary values and everything with the way I'm doing it, which is now in this way. I just made an array of bool values, true false values, with eight of them, or whatever you want to say, eight values in there, that representing each one representing the different materials that a chest or lock can be made of. And if essentially it's very simple, if the same kind of like almost the exact same like thing in concept with the flags or the bool thing or whatever you want to call it, the binary thing I was doing before. But this way, I think it's just a little bit more intuitive and a little bit more readable, because at least for me, it's left to right instead of right to left with the binary things. So the first value in the array is for wood, and then the last value in the array is for Daedric. If it's true, then that material is permitted to be potentially chosen for that generation within that area or whatever. And if it's false, then it's not. And I just changed all these values down here to reflect that. They are essentially they are basically the exact same thing as they was before. They're just using this method, the using an array of bool values instead of the binary ones I was doing of flags or whatever. And then further down, I actually did some new stuff. In this case, I made with the array now, I made a extra check here to make sure if the it just does a quick loop through all the values, and if none of them are true, like if they all return 0, they're all false, then the this value permitted Mathf.Clamp, which I might use later on in another thing, but for right now it's not really being used for besides this. If this returns less than or equal to 0, then it just returns. So it's like, all right, no chest material is permitted here, so just return. And if it's anything else, then it lets it continue on. The chest material method, or I'm sorry, the roll chest material method and the roll lock material method are essentially the same, except for like a few parameters changed here. I did the lock one. I added at the end the chest material after the chest material has already been generated, because I plan to later to most likely have it so, as I think I said, so that the locks they're somewhat restricted on what kind of materials they can be made of, depending on what kind of material chest they're attached to. So you'd want to make it impossible for a Daedric chest to have like a wooden lock, let's say, or a wooden chest to have like a Daedric lock, that kind of thing. But for right now, I'm not using this. I'm gonna deal with that later on, because I don't exactly know how I'm going to do that currently. So that's just there for like placeholder basically. But the actual, and I also wrote some comments here for myself for tomorrow or whenever I continue working on this in the, later tomorrow. This is where the main meat of the stuff that I did today is these two methods. Obviously, the roll chest material on the roll chest material, mostly the roll lock material is just right now is just a copy and paste of the chest material, basically, with just a few names changed here and there. So really, it's just this one. And this is just almost the entirety of it, like in its whole structure, is just a copy and paste of what I did for the jewelry editions mod stuff for that generation of the loot I said, and the rolling of all the stuff. So basically the idea here is that I'm putting values, tickets, let's just call them tickets. I'm putting tickets into a hat. But the difference here of what the thing I was trying to do before is that I was talking about having a limited number of tickets. And then changing that limited, changing the distribution of those limited amount of tickets based on the state of what materials are permitted or not in that case. But in this one, or in this method that I'm doing it, the amount of tickets allowed is for each one is potentially, infinite. Well, at least in this case I have it clamped, so it's at maximum 300 for any single value, or 1 at minimum. So there's no, for right now, there's no way to have absolutely 0, except if it doesn't, if it's not permitted, that material. If that material is permitted, there's no way it could go lower than 1 ticket, but it cannot go higher than 300 tickets in the hat, let's say, in the pile of tickets. And then basically at the end of this, populating, filling this hat with the tickets for the permitted materials, then at the end it chooses one randomly, as pseudo randomly, whatever that you could do with computers and all that. It chooses one of those tickets randomly, and then whatever one that it chooses, it returns that chest material. In this case, it returns that material to up here, so then it can be used later and define the particular material for that chest or lock of that chest object we're generating. So that's the idea. And the way it kind of does that, I'll just kind of go through it, is that I I had this. Yeah, I'll just talk about it kind of line by line. So I first instant or initialize this array, this new array called item roles. It doesn't really matter what the names are, obviously, but this is just to make it. I don't know. This is what they're called in the jewelry editions code. So I just kind of kept them to for the sake of it. But this array called item roles, it's a integer array that is initializing as empty. And then right after that, I do the same thing for a int type list called item roles list. And then after that, like I said, pretty much after that, a lot of this stuff, especially this for loop here, this a lot of it changed except for like the beginning and the end essentially from the jewelry edition stuff. So this middle part is pretty similar in what it does, like exactly similar. It just is different in how the ticket numbers were determined basically here. In the jewelry editions one, I actually used the player luck value, the player level, and the yeah, I think it was the player level as well as the enemy level. It might have just been the enemy level as well as the player luck. I think that was the two major determining factors. Oh yeah, and as well as the actual like rarity value assigned to that particular piece of jewelry or whatever, that particular variant of jewelry. So that was all factored in some weird way I did it to essentially say, you know, how many tickets of a particular item and a particular type should be populated within this list, within the hat, let's say. But in this case, it's actually simpler. It's much more readable, I'd say. So this part's a little bit kind of weird to explain because I kind of forget exactly how it works, and I'll have to see if I haven't tested this at all to see if it actually works. But you know, I have a decent feeling it should generally work, but I will have to see when I when I do actually do some testing. So yeah, I do a for loop here where the how many times it should loop is determined by the allowed materials bool thing that we did from earlier. So it's just the 8 values of the different materials dot length. So it'll loop 8 times basically. And then immediately after, I define a int value called array start, which is equal to the item roles list dot count, which should be 0, I believe. So it basically is saying start doing whatever at index 0 of the array, essentially. But I think if that list, once it starts getting more populated, then it tells it to start somewhere. I don't remember exactly how that part works, but we'll have to see. And then I define just another int value called fill elements, which is basically it's kind of maybe not a great name, but it's essentially just how many tickets should be given for each thing. So fill elements, say if we wanted to give 100 tickets to the odds or whatever, to the wooden material, then fill elements will equal 100. So yeah, that fill elements essentially how many tickets should be assigned to whatever material in this case. And then I was initially doing some if and else if, like a big chain of that with like all 8 of them. Then I said, you know what? Why am I doing this? I could just do a switch case for this and accomplish the same thing, but probably one, much cleaner, and two, probably faster and better anyway. So yeah. So I'm doing switch for the I, which is basically 0 to 7. 0 to 7 in this case, because the um it's only gonna this thing is supposed to only loop 8 times, so it's switching the number 0 to 7. And then in the cases, for each case, I am passing it the permitted materials and then the actual like enum values, so like wood, iron, steel, orcish, and they all each have their own assigned value for that. So like 0, 1, 2, 3, 4, obviously up to 7. And then I'm just casting those to with these parentheses, I'm just casting those over from that type over to int. So then when these are int, then they will be compatible with this switch that is an int value. So then it's like, okay, so let's say if it's looped 4 times and it's on I equals 1, then it'll say, okay, I equals 1, then it'll go to case 3 in this case, which would be orcish. So it'll go down to case 3 and say, okay, orcish, this one is 3. So then it'll run this line of code that is under where orcish is. Now, there is, I think I mentioned this, I'm fairly certain I mentioned this before, but this may look pretty confusing, but it shouldn't be, I guess. It's more intimidating than it looks more intimidating than it actually is. This line here, this single line here is just a shorthand for an if else statement, or an if and else statement, basically. So instead of doing an if and then an else, and being like 5, 6 lines or whatever for the same thing, this is just doing it compacted into one, essentially. So fill elements equals, this is the condition that we're giving. This is the like if condition. the logical condition that we're evaluating, I guess. And in this case, we're doing allowed mats, the array that we did earlier, that we passed here, the allowed materials array, and we're checking the enumerated value here, I, like how many times that this loop is enumerated, and we're checking that that index within this allowed materials array, and we're checking if that value, because it's a bool, it's an array of bool values, so we're just checking if that value in that index of that array is true or not. And we only have to write it like this because you don't have to do anything else for that. It's just like, all right, is it true? Do that. If it's false, do something else. But yeah, in this case, so that's the condition for that if statement, basically. Then the question mark is just there to, like, I guess tell it like that this is that kind of shorthand thing. That's just the syntax for it. And then after that is the first condition, or the first, it's essentially this thing after the question mark and before the hyphen. Is that what it's called? The two dots vertical each other or whatever, the two parallel dots. The value between the question mark and the hyphen, whatever it's called, that value is whatever you want to happen if this thing was evaluates as true. So in this case, we are saying, okay, so when it is evaluating the orcish material in this index here, then it says, okay, fill elements equals, and then it checks if the orcish index value within that array is true or false. And if it's true, then it's like, okay, fill elements equals this, um, what would you call it? Equation or statement, mathematical statement, whatever the hell it's called. Fill elements equals this. But if that allowed materials thing is false, then it goes past that and goes to after this hyphen and then goes here. This second value here, this is the false. This is what gets evaluated for when it's false. And in this case, it's 0. So it's basically saying like, okay, if if this material is not permitted, if it's false, then it just sets this value to 0, and then later on it gets filtered out and it says, okay, so if it's 0, then continue the loop. Like it doesn't give it any tickets. But if it's true, then it does this part and gives it whatever tickets that this is gonna give it. Hopefully that made sense for explaining what this shorthand kind of if else looks like and why it looks like that. It's pretty handy in this case. It's much it may look complicated, but it's much cleaner looking, which is kind of a nice advantage at the end of the day in this case. For me at least. Um but let's look at the actual mathematical statement, I guess, used here, and it's pretty simple. I am just basically doing a mathematical thing called, like, at least at the end here, it does a clamp, which basically says, okay, this value being returned from this mathematical evaluation can only be within the range of what this clamp value has defined. So in this case, it's clamping the whatever value this might become between positive 1 and positive 300. So if this part happens to go to, let's say hypothetically it goes to negative 2000, then this thing will say, okay, make that a 1. Because it's like that's the lowest value that it is allowed. This clamp is allowing it to become. So instead of being negative 2000, it'll become 1. Negative 5000, it'll be a 1. 0, it'll be a 1. And the same deal with 300. If it went to positive 5 million, then it would say, okay, turn that to 300. If it went to 299, it would stay as 299. If it went to 301, it would say, okay, make it 300. That's all it's doing, is saying that this value can only be between these two ranges, 1 and 300. And now this part, I just kind of just threw out numbers because I'm like, I don't know what this is going to be at the end of the day, but this is like, my attempt here. So it's like, I don't know, 95 tickets and then minus the room value mod, which is essentially saying like, okay, so if the room value is positive, then the amount of tickets that'll be removed, the amount of tickets for wood will be actually removed if the room value is positive, and multiply that by 4. But then the inverse is the same. So if the room value is negative, then, negative times negative equals positive. So then this negative or this minus will actually make it into a plus, the negative into a plus. So then if it was a negative room value mod, then it would actually be adding more tickets times 4 of whatever that room mod is to the woods, to the woods pile within the hat to be chosen, the tickets. And then I did the same deal with iron, but slightly more rare and less of a modifier, a multiplier there. And then when I went to steel and the other ones, the more rare ones like steel and higher, I just made the values lower, but I instead of a negative or a minus, I made them a plus. So then a positive room modifier would actually give them more tickets. Then a negative one will give them less tickets. I think that should make sense. Though the actual quote-unquote balance of this, I will have to see, and it'll probably have to be changed heavily, but for right now, it's just placeholder. Um, oh yeah, and then after all that stuff happens, each time it goes through this loop and it gets a ticket number, a fill elements value. It checks if the fill elements is less than or equal to 0. And if it is, then it says, all right, go to the next loop. But if it's not, then it says, okay, item rolls, this being this integer value that we made before, we go through this method called fill array, which takes 4 arguments in this case. Fill array, I don't know where I got this from. I feel like either got it from Stack Overflow, I got it from help. I feel if I had got it from help from somebody in the DFU community, I probably would have wrote it down in a comment somewhere on the in the code, but I didn't, so I feel like I might have got this from like Stack Overflow or something. I don't know. But either way, I was able to do this fill array thing. I can't really explain how it works. It's basically saying, okay, make a list and then have a start a spot, and then the count being how many tickets we have, and then the value being whatever value we tell it to be. So if we wanted it to be like a 20, then it'll just be like, okay, so if so count, so let's say if count said there's 300 tickets of 20 of this value of 20, this number 20, then it'll fill a list here with 300 numbers, or 300 separate numbers within a list of just 20. It'll just be like 20 20 20 20 20 times, 300. It'll just be like 300 of them in a list. And then it'll add that list, or it'll make it into an array or whatever, and then it'll add that to that whole thing. It's basically, this is essentially the little thing that is just being like, okay, so you wanted 300 tickets for wooden chest, so then this just writes out 300 tickets and then puts all 300 of them into the hat. Let's just like make an analogy like that, I guess. But then after that's all done, and all of the tickets, as it keeps looping through, it keeps adding the other tickets for each value into the hat, that same array. Then after all that's done, and the hat is filled with all the tickets that we're going to add, then it continues down to here, where I define this new int value called chosen material, and it's I instantiate it as whatever the hell, as -1. So then later on, if it somehow returns -1, like there's an error or something goes wrong, then I could say, okay, it's negative. If it equals -1, then return some default value, in this case wood, and then give a debug log, write something in the debug log saying something went wrong, essentially defaulting to this value. But if it goes right, then this chosen material will be defined here in this if item rolls.length is greater than 0, then it'll say, okay, chosen materials equals, let's look at chosen materials as the hand that's going to be picking the ticket out of the hat. Let's look at it like that. But then this hand, chosen materials, puts its hand, this hand puts its hand, this hand goes into the hat and then picks one ticket, which this method is doing right here, called pick one of, and it's giving it the item rolls array full of all, it's giving it the hat full of tickets. So this pick one of method, this is one that I kind of know how it's working, but how to explain it I really can't technically. This is something that Pengu, or Pengo, Pengu, in the DFU community, he helped me with at some point. I forget when exactly he helped me with this. I was having something where I was trying to make this whole thing that I used in a bunch of my mods for the rolling and stuff like this. But he helped me make this one. He like basically just was like, here, do it like this, and I was like, oh shit, that's awesome. So thank you, Pengu, for or Pango, whatever, however you want it, whatever your name is is meant to be said. Thank you for the help with this method, and I always copy and paste uh that the fact that you made this basically. So thanks. But yeah, it does this essentially does some magic, and it's like, okay, pick one of the values out of this array that it is being given. So this is saying, okay, this is the functional part of the hand clasping down on the ticket and then picking a ticket, essentially. It's a pretty handy little method there, for my purposes at least. But then once chosen materials picks one of those tickets, it should have a value of either 0 to 7. So it shouldn't do this first part here. It should actually go to this else. And then it actually adds 1 to whatever that value was, because in the chest and the chest materials enums and the lock materials enums, I have this one enum value that the permitted materials does not have, that being the none. The first one, none. And I don't want that to be an option or whatever, so since it's the first one in the array, then I can just skip it by adding 1 to this chosen value, basically. And hopefully there shouldn't be any issues there in the end. And then when that is, when our ticket has been chosen and it has been determined what material it is, then we just return, we return the, we return, it's the same shit. We return the chest materials value as we initially asked for running this method here, roll chest material. And the way it's done is we do return. At least I'm pretty sure this should work. And then we say chosen material, so that's the whatever number it is, and then we are casting it to chest materials the enum value. So say if chosen material is equals 2, like it's a 2, then this cast should be essentially saying, okay, if it's 2, then that means iron. That means iron, the chest materials type of iron, and then returning that value to whatever called for it. I'm pretty sure it should work like that, but I'll have to see with, like, you know, debug logs later on if it does, but that's the intention, is to do that. And then after that's all done, then we have gotten the material that we wanted, or whatever material we wanted chosen, like randomized. We have the chest material, and then it does the same thing with lock material. And then we are going to do with that as we will later on. And that's what I have written down here, is what I plan to do next time I work on this, or tomorrow, whatever, is I'm most likely going to, now that I have the materials determined, at least at their most basic form, whatever, for testing and stuff, now I could say, okay, let's define the other variables with these materials as the main modifiers, and then also the other randomness we're going to add to it and other stuff. Room value modifier that'll change them, such as like the toughness of the chest, the magic resistance of the chest and the lock and whatever, the lock complexity, all those other things. We're going to try and populate those, define those next. But I was very happy with the progress I made today. Much better than yesterday, obviously, but it was important to just say, you know what, it was important at the time to just say, you know what, screw this. This method that I'm trying here is way too confusing right now. It's fucking me up. Just do something, you know, and deal with that, worry about that later until you can, for polish reasons, whatever. And the fact that I did that, I was able to continue here with a way that I know, that I'm comfortable with, and I understand, and actually get some progress done, and hopefully be able to actually, like, do stuff with this, and test it and everything. But yeah, so I was happy with that, but hopefully that was helpful in some way. I don't know, some of the things I explained, but yeah, either way, thank you very much for watching, and I will see you in the next one. Take care.